Hello everybody, my name is Mr. Kugonza and this is my very first online lesson, all because of coronavirus, and I'm going to talk about the slide wire potentiometer. What is the potentiometer wire? Now the structure of the potentiometer wire is what you see on the left hand side. It's basically a wire that is fixed at both ends and lies on a meter rule. That is fixed on a wooden piece of material. Now, it also has other accessories that are not included here, such as the driver cell, the galvanometer, resistors. All those could be additional components, as we shall see later on. So, let us discuss the principle of the potentiometer wire. AB is the uniform wire that you just saw in the previous diagram. It has got uniform resistance, and we have a driver cell connected to it that maintains a steady current through the wire. Because the current is steady, the PD per centimeter, potential difference per centimeter, is therefore constant. So the PD of the driver cell is split all over the wire, and therefore the PD per centimeter is going to be constant. So from any point A up to point B, we find that the PD increases as you move towards point B. So between any 2 points such as A and D, the potential difference between those 2 points is directly proportional to the balance length L. That is the principle of the slide wire potentiometer. So let's look at conditions for obtaining a balance point. When we connect a circuit in the lower section of the potentiometer, that circuit balances up with the PD setup on the wire. So in this diagram that you see over here, we have a cell connected whose EMF should be lower than the EMF of the driver cell. That is the first condition. You must have a cell with a lower EMF than this one. Secondly, the positive terminal of this circuit should be connected to point A, while the other, at the same point, we have the positive terminal of the driver cell connected. Then another condition is that if you move the jockey from, if you place the jockey at point A, the galvanometer will deflect in one direction, and when you place it in point B, as shown in the second diagram, the galvanometer deflects in the opposite direction. So basically, those are the conditions that show that the circuit is well connected and that there is a balance point that you will obtain somewhere between the two extreme ends. How can we calibrate the potentiometer wire? To calibrate is to determine the PD per centimeter of the potentiometer wire. In order to do that, we use a standard cell. That is a cell of known EMF. So the cell is connected as shown in the diagram, and then the jockey is tapped along the wire until a balance point is obtained. Now, this diagram shows we have a galvanometer, a jockey, and a cell all connected to the circuit. So by moving the jockey, tapping the jockey along the wire, there will be a point when the galvanometer shows no deflection. That means that there is no current flowing in the lower circuit. So the potential difference from point A to D is equal to the PD of the wire. Therefore, we say that E0 is equal to KL. So from there, we can determine the value of K. So basically, that is how the potentiometer is calibrated. That is basically our first lesson to understand how a potentiometer works. Thank you.